All right, so we are going to take notes on the physical properties of matter and how to separate mixtures. In a couple days, we will actually get to separate these mixtures, but it's good to get a little bit of information up front. So grab which Cornell note sheet you need, either the first one or the second one. Number 1, what is a property? You should know what a property is by now. A property is a way to describe something. So when I say, this chair is gray, this chair is a solid, this chair is metal, I'm describing that piece of matter. Number 2, what is a physical property? A physical property is a characteristic of a substance that can be observed or measured without changing the substance into another substance. So we're just trying to describe it, but I'm not changing the thing. I'm just telling you I'm looking at it and I'm feeling it. I'm really using my 4 senses, not tasting things. So does it make a sound? What does it feel like? What kind of texture does it have? What color is it? What can I tell about it by looking at it? What are examples of physical properties? Examples are its color, how hard it is or how soft it is, if it smells like something, what does it feel like? Is it soft? Is it slick? Or does it feel like it's like rough? What is its density? Does it feel heavy for its size or does it feel light for its size? Again, density is the amount of mass that was put into a certain amount of space. So if it feels heavy, it has a high density, and if it feels light, it has a low density. State of matter. These are plasma, solid, liquid, and gas. If it's ductile or malleable, these tell you how soft it is. So if I can actually stretch it into a wire or bend it back and forth, those are telling me something about a solid. What its boiling point is, what its melting point is. If when I bend it, does it break? That's if it's brittle. If I can break it, it's pretty brittle. And if it can conduct electricity. We are going to talk about some ways to separate mixtures based on their physical properties. The first one is chromatography. Chromatography is if there are dissolved substances within a solution. Remember, this is liquid. So trying to get the solids out of that, which is mostly anything that is a solution. So the example I have here is ink. I put a dot of my marker or my pen or whatever it is, or the paint, on a piece of paper, and I dip that piece of paper in water, and then over time this water travels up and it pulls all of the solids with it. So that's why you can see really pretty things here. The dot was probably here and the water moves its way up. All markers are a mixture of different colors. All right, so looking here at different markers. And again, markers are different. So if I use Crayola black marker versus Rose Art versus a Sharpie, they're all going to have a different amount of each of these colors that make up their color. That's what makes them different. That's what makes them their own company, because they come up with their own mixture colors. Look at this is interesting. Black looks like a combination of all those colors. Look at the difference between violet and indigo. So it's just kind of interesting to see what the marker looks like. The second way to separate a mixture is mechanical. This is if the parts of the mixture are large enough to be seen. I can actually pull them out by color, size, texture, or composition. Example, gross stuff off of pizza. I can take off all of those nasty banana peppers, or I can take off the anchovies or whatever weird stuff people put on there. I can actually grab it and throw it away straight into the trash where it belongs. This is how they separate through either trash or recycling. So these workers stand in this line, this conveyor belt moves its way into that, and they pick out as much as they can. What of this is recyclable? I don't know, but that's what their job is. And when you put all of your stuff into one huge recycling bin, somebody has to go through and figure out how to separate it. So the paper and the plastic and the glass are all different. They also have different densities, so you could put it into something that will figure out how heavy it is, and it will sort of separate it out. But by hand is always the best way to do recycling or big things like that. The third one is density. If parts of the mixture have different densities, so you put it in water and you see if it floats or if it sinks. Example, garbage floating on water. I can see that the garbage is above water. The garbage has a lower density than the water because it's sitting on top of it. When I have a cup and I fill it with water, this density is 1.0. That means there's 1 gram per milliliter in each square inch of all of this, or square centimeter. Then I put, let's say I drop a piece of glass in there. This glass has more matter per that volume, so it seems heavier, but we don't want to use the word heavy or light. We want to say it has a higher density, and that's why it sinks. Then I put a piece of paper or a piece of plastic. It's going to be up here because it has a lower density. It's going to float. There is less matter crammed into that amount of space. Here are examples. I put some beads in a bottle full of water. I shake it, and then over time they will separate out into their colors. One has a higher density than the other. This is how density columns are made. So there's lamp oil, then there's rubbing alcohol, then there's vegetable oil, then there's water that's green, then there's dish soap, milk. All of this stuff you can put into a cup, shake it up, and over time it will separate based on density. That's just something cool that density does. The ping pong ball is all air. Soda cap is plastic. Cherry tomato, that one was interesting. Popcorn kernel, and then a metal bolt. This is all a separation by density. Number 4, evaporation. When one liquid is evaporated and the solid is left over. Example, sugar or salt water. I put all my solution into this bowl and I heat it with fire, and then all of the water is going to evaporate, and I'm going to be left over with a bunch of salt or sugar. So I could actually capture this in a certain way, but we are definitely not going to be capturing it. That's something that you do in college. I'm not even sure if they do that in high school because it's a pretty cool contraption that you can set up. Number 5 is magnetism. This is when one part of the mixture has magnetic properties. So if you have a whole bunch of crap, you are trying to get the metal out, and that would probably be the easiest thing to do. You can use a magnet. They have a north pole and they have a south pole, and anything that is magnet, which is iron, nickel, or cobalt, will stick to it. Examples are this would be in like a shop where you are building stuff and you want to get all of the metal off the floor. There's a magnet right here, and it is attaching to everything that it's going over. This is also how these things work when you're in an airport. They run this around you to see if you have any metal on you, like a gun or something that is definitely not supposed to be on an airplane. You can't even wear like a belt or a ring that is metal, keys or phone. You have to take all of that stuff out before you get on the airplane. And then this thing here is a metal detector. So he's going around and he's looking for coins, which are metal. The last one is filter. If one part is an insoluble solid and the other is liquid, pass the solution through the filter and it lets the liquid through, but not the solid. The solid is caught inside the filter. So we will actually do this, and you need the funnel, and then you need paper that goes on the inside, and that's a filter paper. And then you dump this through, the solids are going to get caught and the liquid's going to come through. You have one of these in your house. All of the air is filtered through this, so they have air that's coming through maybe your kitchen, and it's pushing all the way through, and then it's coming into your bedroom and it's going through the filter. These should be changed very often. Most people don't do it as often as they should. It catches all of the dust and the hair and all the nasty stuff that's just floating around in there. Coffee, self-explanatory. You put water through it, the grounds, and then that's what you drink. You throw this away because it's gross. This is a filter for a fish tank. So you pump air or the water through one way, and then it sucks it up the other way, and it's cleaning it when it's going through. All right, that is it for the separation technique. So write your summary, take a picture of your summary, and submit it.